Hey everyone. So we are in the business of solving triangles these days, and we're making things a little more complex in that that's an easier task to do if we're dealing with right triangles. Solving triangles means to get all of the bits of information, all of the angles, all of the lengths of sides. And with the right triangles, I've got some weapons in my arsenal, such as the Pythagorean theorem, such as SOHCAHTOA, those right triangle ratios. I could use all of those things if I know it's a right triangle. If it's what we call an oblique triangle, one that is not a right triangle, suddenly we're a little more limited. And so what we learned the other day was that there's a law that involves a trigonometric ratio called the law of sines, and it's super helpful. And it's a pretty basic equation. The length of side A over the sine of its opposite angle. We call that angle A. So A over sine A is going to be equal to B over sine B, which is also going to be equal to C over sine C. And that was really helpful in coming up with some information, given a little bit of information to be able to solve the rest of the triangle. And we recalled from our geometry days, sometimes when you had just certain bits of information, you knew you had exactly one triangle, and then you just had to figure out what the rest of the pieces were. And so we use the law of sines pretty well, but there's some instances where we know we've got exactly one triangle, but the law of sines is not going to get us where we need to get. And I have a triangle drawn up here, triangle ABC, and I've shared three pieces of information. I've got side C, I've got angle A, and I've got side B. And I want to solve the triangle. It seems like, all right, maybe the law of sines is the way to go. But remember, when we did the law of sines, I encourage you to find a pairing of angle and opposite side where we had all of the information, because that would help us get to the other pieces. But I don't have that anywhere, okay? I know side C, but I don't know angle C. I know angle A, but I don't know side A. I know side B. I don't know angle B. And so if I tried to apply the law of sines and set up an equation, I guaranteed would have two unknowns no matter how I tried to set it up. And in algebra, if you have one equation and two unknowns, you're in a little bit of trouble. So I need something else, and that something else is the law of cosines that might help us in these situations. And the law of cosines is actually not completely unfamiliar to you. You know part of it pretty well, because part of it can be applied only to right triangles. And I'm talking about the Pythagorean theorem. Okay, the Pythagorean theorem, c squared equals a squared plus b squared. And a lot of students learn it and say it, a squared plus b squared equals c squared. And then they look at me strange when I write it like this. Why do you have to put the c value first? Well, it's because of this. It's because the law of cosines. And the fact is that this is just part of a bigger equation. And it's part of a bigger equation that we can keep it this short only if we do right triangles. The big equation is called the law of cosines, and it looks like this. C squared equals a squared plus b squared minus 2ab cosine c. Now, I'm sure that looks like a mess and it looks not fun. It's a little bit of a long equation, but really it's super helpful, and it's worth your time to be really familiar with the law of cosines. The good news for us is you'll be able to refer to your notes. I'm not going to require you to memorize it. I think when you do that, the problems over and over, you may naturally memorize it. But for now, let's just look at that. That's going to help us solve when the law of cosines was not going to help us. I also want to point this out. I don't think in your notes I gave you all of the different parts. Looks like I did not. But just as this says c squared equals a squared plus b squared minus 2ab cosine c, we can rearrange this to deal with any side. And hopefully you'll get used to this. I could say So b squared equals a squared plus c squared minus 2ac cosine b. And you can figure out the a1, a squared equals b squared plus c squared minus 2bc cosine a. So rather than having to relabel my triangle, I can apply this in any way. And hopefully you guys get that. If you need to write all three of them out, that's fine. I definitely understand that. That's going to get us to where we get one other piece of information. And really all we need is one other piece of information to be able to go back maybe to the law of sines. I will agree with you completely. The law of sines is a little simpler than this. And so if we can go back to that, that'd be great. Or maybe we can go back to the knowledge that adding up all of the angles will add up to 180. That's a pretty easy way to find one of the missing angles. But let's do this. Let's solve this right now using the law of cosines to at least get us one extra bit of information. And ironically, I think that the equation that we're going to need is the one that I didn't write there. So I'm going to erase these two. I do notice that I have side C and I have side B. I don't have side A. So I'm going to say this: a squared equals b squared plus c squared minus 2bc cosine A. All right. Now let's start plugging things in and see that this is going to, we know all of this information. And honestly, I'm going to kind of break it down step by step, but you could put this whole thing right now. If we're solving for A, you could put this whole thing into your calculator in one step and then just take the square root of it, because this says a squared. So if we want an A, we'd have to take a square root. But let's just drop in some values. Equals 20 squared, that's value of side B, plus 30 squared minus 2 times 20 times 30 times cosine of 60 degrees. All right. It's a long equation. Looks a little messy. There's definitely some order of operation stuff that's important. We do multiplication before we do addition or subtraction, but your calculator knows order of operations. And so we could just put all of this into our calculator and we would find out a squared equals, I'll let you guys put it into your calculator. I'm going to cheat and peek. It looks like a squared equals 700. So A is going to equal, we might say plus or minus the square root of 700, but when it comes to lengths, there's no minus or negative lengths. So A is the square root of 700. And if you do that, you get approximately, remember these squiggly equal signs mean approximately 26.5. And so I've now gotten the third or missing side of my triangle. If it were a right triangle, we'd say we could use the Pythagorean theorem. It's not a right triangle. We're actually using the Pythagorean theorem in its full extent, in its full version. And so I found out that the length of side A is about 26.5. Now, I still don't have angle B or angle C, but please notice that now I do at least have a pairing of angle and opposite side. And so if you really like the law of cosines and want to practice it, we could write another law of cosines equation, but law of sines might get things a little more easily. I could do 26.5 over sine 60 equals 20 over sine B. In fact, let's do that and let's figure that out. A over sine A equals B over sine B. And I'll tell you what, I'm going to do the algebra and rearrange this before I put in numbers. Hope you remember that upstairs, downstairs rule. I'm solving at this point for sine of B. That's got to go upstairs. Sine B equals. This goes upstairs over here. So I have B sine A over side A. If you didn't get that, please take the time and do the algebra. You'll find out that that's how I would solve for sine B. And if I do that, I'm going to punch some of those values in my calculator real quick. Of course, hopefully our calculators are all set in degrees. But B is 20 times sine 60. Close that parenthesis. And that's divided by side A, 26.5. And I get that sine B is equal to 0.6536040783. That's what the sine is. I don't care about the sine. I care about what the angle is. So I need to go backwards. I need to say, all right, if I know the sine, what's the angle? That's arc sine. And so I'm going to do that second sine. Now, if I hit second and answer, which is right above the negative sign, it's going to do the arc sine of the last answer. I come up with 40.81 degrees. They usually ask us to round off angles to the nearest whole angle. So that would be 41 degrees for angle B. And that was really helpful because I still have angle C. Now I could use the law of cosines, which would be a long, messy equation. I could use the law of sines, which is a bit simpler. Or best of all, I could just say, hey, all of the angles need to add up to 180. And I have one that's 60 and one that's 41. Add them up, subtract from 180. I get 79 degrees. And guess what? I've got me a solved triangle, all of the angles, all of the sides, and I've used the law of cosines. All right. So law of cosines, kind of like the Pythagorean theorem on steroids. I'll point out to you real quick that when we do have right triangles, if I had a right triangle, and this was my right angle, my 90-degree angle, you may remember that cosine of 90 degrees, last chapter we were calling it pi over 2, cosine of pi over 2 is 0. And so what that would do, if this angle was 90 degrees, all of this would get wiped out because it's being multiplied by 0. And all of a sudden, look where I'm at. I'm at the Pythagorean theorem. I just kind of have my A's, B's, and C's switched around. So it's very similar, the law of cosines, to the Pythagorean theorem. It's kind of like the full extent of it. But if it can get us one piece of information, that's super helpful. And when the one piece of information we need is the third missing side, we could just run this straight into our calculator and we can find it pretty simple. Then we'll solve the rest of it maybe by going back to the law of sines, maybe by just adding up our angles to 180. In the next video, we'll look at maybe a little bit trickier if we're only given the three sides, we're not given any angles. And we'll also look at another formula for coming up with the area of a triangle. But you can practice some of these now where we're given side, angle, side, and we solve the triangle starting out with the law of cosine.